All right, so this is a problem where technically you can get away with graphing it on your own, but 99 times out of 100, you're not trying to do that, especially on a no calculator section. And if you see yourself feeling like that's the only way you can solve it, you definitely want to skip and come back. So how do we solve this? Well, if they want us to know first where the two lines intersect, and then once we figure out what those coordinates are, we're just adding them together. They're just giving us an extra step on a problem that's pretty standardly given to us in our math class. That's classic SAT. So how do we do this? We're going to need point slope form. Now, for any of us that forget what that is, point slope form is what we use to convert a bunch of this type of information into slope intercept form, how to convert it into y equals mx plus b. What we have right now is not enough to directly write this equation, but if you put it into point slope form, which is y minus y1 equals m outside of x minus x1, that after you plug it in and get this y by itself, you're going to be able to turn it into this equation here, and then you can do whatever you need to with that. So we're just going to do that now with our first equation. They tell us the slope is 2, so we can write it with 2, and then they give us the equation where the coordinates where y is 8 and x is 1. And then now we just go ahead and solve for it. So this becomes y minus 8 equals 2x minus 2. Then this becomes y equals, you're going to add 8 to both sides. So 2x plus 6. So we got one equation here done. Let me put that off to the side. All right, and then I'm going to then do the same thing and figure out what our other equation of our line is. Because once you know both, you literally just set them equal to each other, because that's what it means to intersect in algebraic form. So we need to first know what the slope is. So this is actually a little bit harder for us, but not harder, but just to give us an extra step. And we do that by by y2 minus y1. So 2 minus 1, x2 minus x1, so 1 minus 2. And then we see that this has a slope of 1 over negative, so it has a slope of negative 1. And now that we know that, we can just rewrite that into slope intercept form. And that would go outside of x minus x1, y minus y1 equals that. And then we can pick any of these two lines. I'll just go ahead and pick the first one there, those two coordinates. I'll just choose this one here. So that's 2, and this becomes 1. After I distribute that, I end up with y minus 2 equals that. Y equals negative x plus 3. So we have our two equations here, and now we can just set them equal to each other, really. Just to make it a little bit more clear, let me just put like this one in red and this one in purple. And all we're doing is setting them equal to each other. So I'll just say this is equal to that. And then once we solve for our x, we're going to be able to, actually I'm going to want to keep this copied. Doop, 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 doop. All right, now, because that'll be useful a bit, you see. We can get x by itself here. I'd rather just move that x over here so I can keep everything positive. So plus x, and then minus 6, so I end up with negative 3 equals 3x, which tells me that x equals negative 1. All right, now that I know that x equals negative 1, I can plug that back into our slope-intercept form equations here, either one, and then solve for y. This one's going to be easier to solve, so I'll plug it into that. So now it becomes y equals negative 1 plus 3, so that ends up becoming just positive 1 plus 3, and then y ends up equaling 4. And then we add them together, we're going to add these two values together, which means it is now negative 1 plus 4, which equals 3, and the answer is B. Remember, they want us to solve for the value of a plus b, where a represents the x coordinate and b represents the y coordinate.